Alright. Alright, so is everyone ready? I mean, I'm ready, so.
We're gonna get started on our next session.
Okay, our next session is starting.
Alright, hello everyone, my name is Andrew, and my summer project is titled Quadruped, a four-legged chassis as seen here. So, my name is Andrew, and some fun facts about me. I am in the 9th grade, and I have 1 year of FTC experience. And I also did 1 year of FL as well. It's my first year on the A565 Technibots, and I'm a certified build member, which means I'm on the build team, and my name begins with the letter A. Some people think it begins with the letter B, so you know. So these are the topic overviews I'm going to be going over in my presentation. First off, my CAD process, my prototyping process, my programming experience, as well as the final build, which is shown here. So here's the agenda. We're going to first be talking about why did I decide to choose to build this robot. We already have robots with wheels. Why should we build a four-legged robot? We're also going to talk about the CAD process, on designing the robot as well as refining it, building and testing, programming, touch on documentation, and finally I'll conclude with what I learned and some tips that I might offer for the next season. So, why should I build a robot like this? Well, we got bored of conventional four-wheel chassis, so we wanted to try something new. It's just for fun, building a four-legged chassis. It's also really cool. Like when I walked in, everyone was staring at this, right? I hope. And just imagine, you see this in the photo, right? What if this was actually FTC legal? What if this happened? Like, what if this was implemented in every single competition? What if wheels were just not banned? I mean, this is cool, right? So, this is how I began my design. First off, I would brainstorm what I had to do before I actually jumped into the CAD. First off, I knew that there would be a lot of torque required to lift the robot off the ground. So I had to gear a torque servo down. To do this, I found some gearboxes on GoBuild. And using this gearbox, you can easily attach a servo and a gear together to gear it up or down, depending on what you want to do. I also knew that this would be incredibly expensive. This gearbox is $120. So I also had to cut down on the cost by creating a file out of this metal custom gearbox and 3D print it in real life. And you can see there's some 3D printed gearboxes in the robot right there. And finally, I knew I had to do some 3D movements. If it only moved horizontal, it would slide on the ground. If it only moved vertically, it just bounced up and down. So I combined the two servo gearboxes together to create 3D movements in this format, and this is how they would move. You can sort of see this animation on how it might waddle forward and backwards. It'd go down, back, up, forward, down, back. It's kind of like walking. So this is my CAD prototyping. So why would I use CAD? Why wouldn't I just go straight into building it? Well, just like Derek talked about before, CAD is computer-aided design, which means it's completely virtual. If it's virtual, it's very easy to make changes very quickly. For example, if I wanted to take one of these gearboxes off, I'd have to unscrew so many screws and take apart so many other gearboxes. But in CAD, I can just pull it out and it's already perfect. So it's quick and easy to make changes. So this is my first CAD prototype design. You can see the 3D configuration with the two servo gearboxes right here, as well as an idler on top to make sure that nothing slips off. Now, you can't, it's almost impossible to CAD something perfect first try. So I had to also evaluate my CAD. And what problems occurred? Ground clearance. You can see that the servo gearbox was attached vertically, which is very close to the ground. That's like 1 inch clearance, which is very bad for a robot. So ground clearance was clearly an issue, but also it was an unstable structure. Have you ever tried standing on one leg? You probably fell over and broke your hips. But if you stand with 2 legs, you can stand up perfectly, right? I hope so. So that's also another problem. So what I did was I just flipped the servo gearbox horizontally, and now there's an angle structure, which means it's wider, which will provide more stability, as well as stabilize the structure, and it improved ground clearance. So that's pretty much the main improvements I did before I got into my final CAD prototype. So this is what the CAD looks like. There's bearings, there's an idler on top, this is a 3D printed gearbox right here, like I mentioned earlier. And this is a 3D printed husk to make sure it gets contacted flat on the ground. So my final leg. So what do I do after? Now that the CAD is complete and I know that there is nothing wrong with one leg, I just have to do it for 4 legs. So the reason why I CAD out everything for good measure and not just CAD out one leg is because I want to know how I might be able to build this in the future. So I just CAD out everything, maybe plan some things I might assemble first, some things I might assemble last, and then just continue in from here. That looks cool, right? Right? Yeah, that's cool. Okay. So here's my build execution. So I first have to take every piece from CAD. Each of these, thank you. Each of these pieces were downloaded off of GoBuilder, and you can buy these. You can buy each of these in bulk. And so the way that I would actually buy these pieces is I would translate each of the CAD step files into a BOM file, which is a bill of materials. Just basically a list of things that you might be able to buy and how much. So you can see Doodle Sheets, this is the name, this is the link, and how much, and my name, so like people will sort it for me. And so with these pieces, all of this assembles one leg. So, it's quite costly. And after assembling one leg, you just assemble the entire robot. And after building the first leg, going through a ton of problems, I learned from them, and I can assemble the rest of the robot much faster, much easier, and it's much more sturdy. So now programming, but from a builder. You can tell how downhill that would go. So this is a program exoskeleton. Just like CAD, I can't jump straight into programming. I have to brainstorm what I have to do. And while coding can get messy, you can organize it using flowcharts or pseudocode. In this case, I sort of combined both. So you can see that's like the flowchart on the side with like a little bit of state like flowchart, as well as pseudocode, just words, English words that you can slowly translate into code. So now with that complete, I began the programming process. The first thing I had to do was configure all the servos, just configure it to the control hub so it can communicate with each other. Rather than saying this port does this servo name does this, it's much more organized. So rather than saying person 1 do something, say Andrew do something. That's much easier to understand. And so now I have to create the walking algorithm. And so for this, I use a state machine. A state machine, in a nutshell, because that's the only way that I can explain it, is it's just one piece of code that triggers another, sort of. So you can sort of see from this final iteration, I have different states. There's an up forward state, there's a down state, and there's a back state, just like how the robot was moving earlier. So pretty much using time, once the up forward state finishes, then it will trigger the down state, then it will trigger the back state. So whenever each state finishes, a new state will be activated, and the servos will turn accordingly. So, documentation, the part that I dread the most. Most people hate writing. So, this is quite just a huge pain to actually do, but it helps you so much. For example, if you run into a problem and you run into it again in the future, this will help you out. If you find a solution, this will also help you out. And you can also use this to flex, or also, just show that you did a lot of work. So finally, I'll go into my conclusions and I'll demo one of the legs moving. I emphasized one, which was why I'll explain now. So first off, my conclusions. I extended on my pre-existing engineering knowledge, which means I built all of this on my own. And normally, each builder in FTC would build one subcomponent to build an entire robot. I built all of that, which impresses me even. I was forced to write down everything, but I still enjoyed doing so. And wow, and the engineering notebook actually looks pretty professional. And finally, I created a functional program for one of the legs. Not for all of them, only for one, okay? So yeah, in the huge conclusion, I had a ton of fun this summer. And so I'm just really happy that I actually accomplished something over the summer break. So I'll go ahead and demo, and then we can start the questioning. I hope it works at least. So this is the one leg that's going to be moving. Wrong gamepad. So you can sort of see that movement, right? Alright, I hope you all clap for me. I'm very scared right now. Alright. So let's go ahead and begin the Q&A session. How do you do that? Oh, yeah, you.
So you were describing how you built the robot, and you said it was a really long process. But how many months did it take you to from start to finish, and then for just that robot?
Around the first week of summer. So the entire process took 11 weeks, or a little bit more than that actually, which translates to about 3 months. So yeah, so the engineering notebook, it provides you with 11 weeks. Okay, well, I documented 11 weeks of work, which is just from start to finish.
You said it was pretty costly. Did you fund it yourself or outside sources?
Sponsorships, mainly from sponsorships.
But it's really friendly work.
Yeah, and I also wanted to cut down on costs, like I mentioned in the slide earlier, by 3D printing the $120 gearbox. Yeah.
For 3D printing parts, how hard is it? And did you basically just take the file from the GoBuilder website and put it into the 3D printing software, or do you make some changes to it?
So I can answer the second part of your question. For 3D printing, I don't specialize in that, but okay, he's not here. But Victor is the person that I on our team that I contacted to 3D print. But so for the file, right? You can download a step file from GoBuilda. I'm not sure if it might be some legal reasons or anything, but you can't just directly 3D print that. So what I did was I took like one of these step files, which is just like a 3D model of the gearbox, and I remade it like with a 1-to-1 ratio. So it's exactly the same. And then I sent that file off to 3D printing.
Okay.
Yeah.
Yeah. To expand on that, you can take GoBuilda parts itself, and then you can modify it through Fusion.
Yeah, you can
360.
modify it
You
too.
just need to
Can you do
unlink
the
it.
same thing for red parts?
Yeah.
Your right parts are the same. But you can't modify it directly. Like you can't just delete this part. You have to remake it before you can modify it.
Why did you choose full legs?
Why I choose what legs?
Full legs.
4 legs?
Like four
Why you
legs.
do 4 and not 3 or 5 or 6 legs?
8 wheels, okay. Alright, so the reason why I chose 4 legs, it's like the perfect balance between having like being able to walk and having like it's being too expensive. So remember, like each of these servos are incredibly expensive and they break easily. Obviously, the more legs, the cooler and the more stable. But the less legs, with just 1 leg, you can't walk. But with 2 legs, it's incredibly hard to balance without some sort of gyroscope or other balancing mechanism. So 4 is like the perfect balance between each.
Actually, you could also mention the port limitation.
And port limitation. So each of these expand the control hub and expansion hub. I didn't have this problem, but you see there's 2 hubs right here. So each of these hubs can contain 6 servos, and I have 8 servos. So that means I would need 2 to complete everything. But if I had, I can't do math. If I had more than 6 legs, then that means I won't have enough ports to make this thing FTC legal, because you can only have 2 hubs to use.
You ended up with 2 servos per leg?
2 servos per leg, yes.
One servo is...
One servo controls horizontal rotation, another one controls vertical rotation.
So you were concerned about FTC legal port hubs, but not about whether or not you could walk in competition.
I mean, I was concerned about walking, but I just couldn't do it.
All right.
Why are you clapping at that?
The whole thing was great.
Alright, yeah.
Why did you use servo motors instead of hex motors, since they're more powerful and yeah?
I mean, hex motors?
Core hex.
I mean, yeah, core hex. right.
Core hex. So that's how should I explain this without like being insulting?
$500.
So core hex, I've used it. It's really low torque, if I say the least. Core hex doesn't offer that much torque, and even if I gear it down, it's definitely not enough to sustain this. But there's also a sizing problem. But also there's also not enough ports for each of these for that many core hex motors. So yeah.
So you're going to continue to make it walk, or...
Yes, I definitely will. I've gone this far. I normally throw my projects away right after I present it. This is beautiful, so I have to continue.
So when you're lifting 1 leg, you got to figure out that the body should be balanced with the rest of the 3 legs so that it can freely lift up and...
So the mechanism that I'm trying to do is control 2 legs at the same time, because it's wide and the ground contact is actually pretty wide. As long as 2 legs are on the ground, it's relatively balanced. So as long as the other 2 legs move fast enough, it can walk pretty well.
Yeah, just to clarify, this is not the best programmer in our team. He's a builder.
I mean, I
But
programmed
he's
for 1
talented
day.
To learn programming in
Yeah.
1 week. So he's still working on it.
Actually, if I'm gonna be honest, I learned it in 1 day.
Just have a question. What CAD software in the software is used to document?
Wait, so what I use to CAD and what I use to document?
No. Just curious because I'm pretty new to this whole design thing. So you mentioned you use a CAD.
Yeah, so you're wondering how I
You use some kind of a CAD software.
how I made this, right?
Fusion.
Okay, so you use Fusion 360, and so there's a ton of CAD softwares out there. There's actually a lot of them recommended for FTC, but we just chose Fusion because it's been a long tradition to use.
And it's free for education.
It's free for education.
So, other than walking, do you think the robot, like, after you finish it, get it walking properly, do you think it can support other, like, motors for, like, other functions?
Definitely. So these servos provide a ton of torque. So as like 5-turn torque servos, as well as it geared down with a servo gearbox, it provides enough torque to. I haven't tested how much weight, but definitely enough for other functions, other potential functions.
So right now you have your robot able to move forward and backward, assuming you get the other 3 legs.
Assuming, yeah.
You're able to move forward and backward. What other range of motion are you looking to try to incorporate with it? Any type of strafing, rotation?
Yeah. So the main goal I was trying to do, trying to get to before coming to this presentation today, was letting it at least be able to walk forward and backwards and maybe turn so the robot can go anywhere. But I was also thinking about, just like you said, strafing, just by controlling like it going side to side like this, and also controlling the vertical like up and down, like how high, and it'll keep that position while walking. It's a little ambitious, but one day I will be able to do it.
So you built like all that robot, but like, is there any special like advantages that you're gaining that any other chassis or anything?
Knowledge. But wait. So actually, could you rephrase your question real quick?
So like, can this robot do like something better than any other robot can do?
Possibility.
Yeah, I was about to mention that. So if you like see wheels, right? Wheels can't drive upstairs unless it's big enough. But with this can also almost be any size to try climb upstairs or other obstacles. So it can, it's definitely better than wheels in that case, but it's definitely slower. No more other questions. Let's go.